guys. So today I am off learning about fabulous math things, and you are going to learn about, well, I guess continue to learn about constant rate of change, constant of proportionality, and now you're going to put the pieces together and talk about a new kind of relationship, okay? And we'll find out what that is at the end of this lesson. So today we're going to be talking about this cute little girl, Felicity, and this really handsome young man, Bruce, and they're going to go on a 40-mile bike ride. Okay, you have some notes you're going to follow along. It's called cross-country cycling. So make sure you have that paper. I would highly suggest that you do this in pencil. So if you don't have a pencil, go donate a shoe to my box and borrow one. Okay, so the first thing that we're going to do, I'm going to move this over here, and then we're going to talk about where they are. So Felicity allows Bruce to start at the 6-mile mark on the course. So here's Bruce's side, okay? So he's going to start right here. This is where Bruce is going to start. And Felicity rides at a speed of 10 miles per hour, okay? And Bruce rides at a speed of 8 miles per hour. So on the number line, what you're going to do with your pencil is you're going to mark where Bruce would be to get to the finish line and where Felicity would be to get to the finish line. So go ahead, and what that's going to look like is Felicity starts here at 0, right? And so she rides at 10 miles per hour. So after 1 hour, she'll be at 10 miles. After 2 hours, she'll be at 2 miles. 2 hours, she'll be at 20 miles, sorry. After 3 hours, she'll be at 30, and after 4 hours, she'll be at 40, okay? So Felicity's going to take 4 hours to finish the race. Now Bruce, on the other hand, he is only going 8 miles per hour. So if he starts at 6, that means he's going to get to right here to 14. Okay, so your job right now is to pause the video and finish in that number line. Okay, so look at the number line. This is kind of what it should look like. Notice that Felicity finishes in 4, but Bruce is going to take a little bit more than 4 hours to finish. Okay, so on to the tables. What we're going to do now is take what we just did and put it into our table. So for Felicity, let's do Felicity first. We know that at 0 time, where was she? She was at 0, okay? And after 1 hour, she was at 10 miles. 2 hours, she was at 20 miles. 3 hours, she was at 30 miles. 4 hours was 40, and 5 hours would be 50. So if you think about what's happening here, we are multiplying by her rate, which was 10 miles per hour, okay? So basically I'm doing hours times 10 gives me Felicity's distance, okay? And let's go and talk about Bruce. So Bruce was because Felicity gave him a head start, remember, after 0 hours, he was already at 6. Yes, and so that means after 1 hour, we know that he was at, okay, so when we look at Bruce, this is kind of Bruce's process, right? This is where he started at 6, and because his rate was 8 miles per hour, he was here. But the weird thing is here in my process, I can't really do +6. It works here, but that doesn't work here. So we have to start to think something else is going on, right? So let's go and let's ask some questions, okay? This is where we can't find it in, so we need to go to the outside. So we're going to look to see if Bruce and Felicity have a constant rate of change. Okay, so here is our information. Slide this over here so it's out of the way. The first question is, does Felicity's situation have a constant rate of change? Now remember, for constant rate of change, we're going to be along the outside. So we're going to look over here, and that's going to be your ratio, remember? Change in y over change in x. So from here to here, we know that it's 10. We know this is 10. This is 10. We know this is 10. We know this is 10. And over here, it is going by 1. So we know that our constant rate of change for Felicity, the ratio is 10 over 1, and it's the same. So we know that her constant rate of change is 10. So the answer is yes, she does have a constant rate of change. Okay, so now we have to figure out Bruce's situation. Does Bruce have a constant rate of change? Okay, he is over here. So from 6 to 14. Okay, so Bruce has his rate, if you notice, between these, if you're looking, it's 8, right? And it's 8 on all of these. And then when you come over here, we have it, it's counting by 1, so we know our rate of change over here is 1. So when you look at the ratio, the change in y over the change in x, you get 8 over 1, which means that Bruce does have a constant rate of change of 8. Okay? So now the question, we have another question. So we're going to go and look at the tables now. Now we're going to ask, does this represent a proportional relationship? Now, proportional relationship means that we have the y over x. So remember, this is your constant of proportionality, your y over x, not the change in y. So when you come over here, is 10 over 1, right? And you have 20 over 2, you have 30 over 3, you have 40 over 4, and each of these comes out to 10, okay? So the answer for Felicity is that yes, she has this constant of proportionality which equals 10, okay? So we know that this is a proportional relationship, okay? Now, Bruce, on the other hand, his, remember, was 8 over 1 here, and here it was 14 over 2, which is 7, and 22 over, oh wait, no, 14 over 1, sorry, which is 14, 22 over 2, which is 11, 30 over 3, which is 10, and so on. So if you notice, there is no constant of proportionality because the y over x is not. So we know that this is not proportional. So Bruce doesn't have a constant of proportionality, and Felicity does. Okay, so the next question is, how long does it take Felicity to finish the 40-mile course? And so what you can see is that she gets to 40 miles after 4 hours, okay? Based on the work that you did on your table. So then the next one asks, how long does it take Bruce to finish his 40-mile course? Well, when you look at the table, at 4 hours, he's only at 38 miles. Okay, and so we know it's going to be at least 4 hours, but we have to do a little critical thinking here. So when I get to 40, that's 2 more miles, right? So it takes 2 more miles to get to 40. So I have to think about my 8, right? Because he goes 8 miles per hour. And so if it's going to take him he has to go 2 more miles, that's going to give me the fraction of 2/8. But when I simplify that, it comes out to 1/4. So if I think about 1/4 of an hour, that's going to be 15 minutes. So Bruce is going to take 4 hours and 15 minutes. So now we want to talk about writing an equation. Okay, when I go to write an equation, this one, Felicity, is what we've seen before. It says that in order for distance is y, we know that we have to multiply by 10, and that's going to give us our, we have to multiply the time by 10, and that gives us how far she went. That's our distance. So here's our equation for this one. Over here, writing an equation to describe the relationship, it's a little different. We're still trying to find distance, which is y equals, but I had to multiply because remember my constant rate of change was 8. So I had to multiply my hours by 8. But because Bruce got a head start, I also have to remember to add the 6 because he started at 6. He didn't start at 0. So in order to write this equation, I have to remember my constant rate of change plus the piece that he started. He got a bonus. So that's how you would write this equation. Y equals 8x plus 6. So now you're going to pause the video, and I want you to use your table, and you're going to plot your points on the graph. All right, so once you've graphed, and you can do, if you did it in 2 colors, that's fine. And make sure you label your lines. It asks you this question. I'm going to move this maybe down here for just a second. Whose line does the ordered pair 3.5 and 34 fall on? Okay, what does this mean in the graph? So I need to go on my x, because this is first, right, to 3.5, and I need to go to 34, which is like right there. Okay. And whose line does this fall on? This looks like where they meet, right? So Felicity and Bruce meet at this point. This is where Felicity catches up to Bruce because Bruce got the head start, okay? So part B says the equation 8 times hours plus 6 equals 40 can be used to find h, the number of hours it would take Bruce to finish the 40-mile course. How would the equation change if it was a 110-mile course? Well, it would change based on 8 hours plus 6, because this is not going to change. What Bruce did, his process is the same. Okay, so what will change is we're going from 40 miles to 110. So what I'm trying to find will be 110. So that's how my equation would change. So then the question asks, whose line does the ordered pair 1.5 and 15 fall on? So we go to 1.5 and we go to 15, and we see that that falls on Felicity, or, oh, it's Felicia? Have I been saying Felicity this whole time? No, it is Felicity. They spelled it wrong. Somebody got a little, okay, so we're going to go with Felicity. It's on Felicity's line. What does it mean? That's a good question. I'm going to pause the video, and you guys are going to think about what does this mean on the graph. Okay, well, to me, what it means is that right now, after 1.5 hours, Felicity is only at 15 miles. Okay, so 1.5 hours equals 15 miles. So then it asks us about the equation for Felicity. Well, Felicity was just that simple multiplicative equation, right? 10 times the hours gives me 40. But it says, well, what if the number of hours it would take Felicity to finish a 40-mile course, right? But what if, how would it change if it was a 20-mile course? So again, it's still going to equal 20 because her rate is still 10 miles per hour. Her rate didn't change, just how far she was going. So now really it's only going to take her 2 hours to finish the course. Okay. And then the last one says, when are Felicity and Bruce at the same place on the course? How can you tell from the graph? They are at the same point at 3 hours or 30 miles because their dots overlap, right? Okay, so based on this activity, now you can make these things be said. both of these tables had a constant rate of change, okay? Both of the graphs had a straight line, but they didn't pass through the origin, okay? One of them was not proportional. Both of these representations, this is this new word, are called linear relationships. So now we're adding a new word, which means linear. Linear just means line, right? So even though they were not both proportional, they can both still be linear, okay? And that's kind of where we're going to end for today. Your job right now is to make sure this activity is completed, and you're going to glue it into your ISN. No.